It's already in quadratic form. My a value is 2, my b value is -4, and my c value is 4. Okay? Because a is positive, we're going to say we know that this opens up. Let's go ahead and find the axis of symmetry. So x equals -b over 2a. B is already negative, so negative -4 is going to end up being +4, and then 2a. So negative -4 is +4, because that's like we're multiplying by -1. 2 times 2 is 4. So my axis of symmetry is yet again +1. X equals 1. So that's going to be that vertical line at x equals 1. Right here. Okay. Now, let's go ahead and find the vertex. So we're going to put 1 in right there, and I'm going to change this to f of x, because I just like it to keep my work organized. So this is going to be 2 times 1 squared minus 4 times 1 plus 4. 1 squared is 1, so I've got 2 minus 4 plus 4, which is 2. I'm going a little bit faster on this example because you've already seen a couple. If you have questions about where my numbers are coming from, though, ask. So my vertex then is 1, 2, which means over 1 and up 2.
Okay, now the second tip that I gave you guys was to choose 0 as one of your points, because that's going to help us get that y-intercept. So let's go ahead and do that now, since it's right before 1. So what we're going to do is we're going to go into our function and we're going to plug in 0. So that means I'm putting 0 in place of every x. Okay, 0 squared is 0. And then I've got 2 times 0 is 0, 4 times 0 is 0, and then plus 4. The nice thing about working with 0 is it tends to make everything disappear and leave you with nice, easy to work with problems. So that means that the y value when x is 0 is 4. So that means on my y-axis, I'm not going side to side at all because my x is 0. I'm going up to 4. So now I've got my y-intercept of 0 to 4. Okay, now remember to use the fact that this is a reflection line. So this is 1 point to the left, so I'm going to go 1 point to the right. And that gets me an ordered pair of 2, 4. And now we just need one more. I always like to have at least one negative so I can see what's going on over here in this quadrant. So let's plug in f of -1. It's going to be 2 times -1 squared minus 4 times -1 plus 4. -1 squared is +1, so 2 times +1 minus 4 times -1 plus 4. I'm just following that order of operations. 2 times 1 is 2. -4 times -1 is +4, so that changes to plus 4 and plus 4. And then 2 plus 4 is 6, plus 4 is 10. So I have a point at 10. So that means at -1, so that's here, I'm going up 10. My mirror of that, this is 2 points away from my axis of symmetry, so I'm going to go 2 points away over here, and that is 3, 10. And you can plug that in to check if you want. I'm not going to right now because I know you guys are done listening to me talk about this. So the last step is to make this into a U and then fill in my remaining characteristics. So that goes up, and this one goes up, and there's my parabola. It did open up as expected. I have a minimum because anytime I open up, I'm going to have a minimum. It's at that vertex of 1, 2. There is no max because it's going to continue on forever. My domain, as with every quadratic function, my domain is going to be all real numbers. The one exception to that is if you have a real life scenario type problem and there's something about the situation that restricts the domain. But for most just basic functions, quadratic functions, your domain will be all real numbers because you can plug anything you want into this x and you'll get an output. The range, however, is restricted. The bottom of this parabola is 2. So the lowest possible y value is 2. And then it continues on to infinity. So that's going to be, it is equal to 2. And it's a hard, it will never actually equal infinity. All right, and that's it, guys. Luckily, I've made you listen to a whole lot of practice, but luckily there's not an application. So go practice graphing. Let us know when you're ready to take a mastery check.